Hey everyone, today we'll be going over the Blind 75 in TypeScript, and today we'll be focusing on the problem container with the most water, and without any further hesitation, let's get started. Hello everyone, today we'll be going over the Blind 75 in TypeScript today, and today we'll be focusing on the problem container with most water. Now, before we get started, make sure we have written out all of our questions that we will be going over to solve this problem. First, we need to ask ourselves what the input's going to be, what data structure / algorithm we're going to use, what to do with the data, and finally, what our output's going to be. Now, to go over the question, you're given an integer array of height of length n. So, from our input, we are given an integer array. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and I height of I. Now, given the fact that we have two endpoints and we're dealing with an array, we're going to be dealing with the two-pointer technique. Find two lines that together with the x-axis form a container such that the container contains the most water. And what we need to do is return the maximum amount of water a container can store. So it looks like we need to return the maximum amount of water a container can store, which means we will return an integer. If we were to look at our example, so the container with the most water means that, hey, with a combination of two of the following endpoints, we need to get the area of the entire container. Because some may ask ourselves, if we were to look at this example and have height equals all the following numbers that we would have, and we would search from here all the way to here, we notice in one case that we need to look at the x-axis as well, because you may be thinking, oh wait, what about 8 versus 8? Well, that would not be the container with the most water, because we need to look at the two lines that form the x-axis to form a container. So there's a reason why we have 49 in here whenever we are looking at our given example, compared to, say, someone may think, oh, if we just multiply this and this, but we have to look at the spaces between each of the following lines, which makes this problem a little bit tricky. Because so for this example, if we have each of the following numbers in our array, and the output will be 49 for our given area, the reason is the above vertical lines are represented by the array, as we know. In this case, the max area of the water, which is the blue section, the container can contain is 49, because we look at the spaces between each of the following lines as well to form the area, because area equals base times height times height. So what we will do for our following data is that we are going to first initialize two pointers. I'll just put this over here. And I'll put in some other notes as well. What we need to do is that within our given area for two pointers, we need to maximize the area between two lines by moving inward from both ends, as indicated by two pointers. We go from one end of the array to the other end of the array, and then we always move the pointer pointing closer. To check the area. So what we will do with the data is that we're going to initialize the two pointers, and then, since we already know that within our given array, looks like we will indicate while the left of the array is going to be less than the right of the array, and we're just talking about the position while we are just moving one pointer to the other, because we're just initializing their indexes, because we know within the x-axis that we have, there is no vertical line that is going to be sporadic. We are looking specifically the x-axis and the y-axis, but really, since we already know it's going to be in order, we already know specifically that we have the left-hand side, which can start at the lowest point to the highest point of the x-axis. And while the left is less than the right, we're going to calculate the current area as min height times the distance between the 2 pointers. And we're going to update our max area if the current area is greater. And we will move the pointer while updating our max area. So for us to be able to get started, what we'll be doing, as stated before, is that we're going to first initialize our 2 pointers. So we're going to let left equal 0, let right equal the height dot length minus 1, and we are going to let the max area equal 0. And while the left is less than the right, we're going to initialize some constants here. Constant height equals the math dot min height of left, height of right, constant width right minus left, constant area equals the base times the height, and then the max area equal math dot max area. And the reason why we have 2 of these is just to account for the edge case for whenever we would have 0 in that case. So alright, so if the height of left is going to be less than the height of the right within our given array, so we're just moving the 2 pointers accordingly. We're going to increment our left. If not, then what we'll be doing is that we're going to be decrementing our right on the 2 pointers as they are moving throughout the rest of the array. And finally, we return the max area. And now we're just going to run this to make sure that it passes all of our test cases. And it does over here. Yep, it accounts for all of it. So now what I'm going to be doing is that I will be submitting. And it all checks out. So yes, right now our time and space complexity for our following solution is that our time complexity is going to be O of n, where n represents the size of a given array, and given the fact that we are not storing anything at all and we're just retrieving a given area, which is our max area, our space complexity is going to be O of 1. And so yes, this was Container with Most Water in TypeScript. Thank you very much for taking time to watch this. If you found this video helpful, be sure to feel free to please like and subscribe. And if you have any other questions as well, please put them in the comment section. And as always, take care. Cheers. Bye-bye.